Here we have a 2018 MacBook Air 13-inch that came in for data recovery. Coffee was spilled on this MacBook and the customer needs data. She does not care about the laptop, she cares about the data inside. And I do not know if this laptop has been to another shop before. We already disassembled the board and the board looks something like this. Small, tiny board. And right off the bat, we had a problem with the headphone jack motherboard. And a lot of things connect with this board. So Big Boss already replaced that board. And right now the laptop is charging at 5 volts and not 20 volts. That's a problem. Look at that tiny little board. Corrosion everywhere, so it does not make sense to work on this board. We just changed it. We have a similar donor board that we extracted this from. We put it on the customer's laptop and we still have the same issue. I mean, if we have this much corrosion on this board, God knows what's on the motherboard. I was told by Big Boss that we do have some what looks like liquid damage at the charging ICs, the CD chips 1 and 2, and those can cause the laptop to charge at 5 volts and not 20. I see a lot of mess here, but before we get into this area, why not just quickly go over the board? Customer cares about data, and she does not care much about the laptop. If we are able to fix both the laptop and she gets her data back, perfect. If not, then she understands that we are doing this for data recovery only. Those two caps do not look good. Let me just do a quick measurement while doing the inspection. We hit 2 birds with 1 stone. We do not have a short, and we do not have a short. Now, I did not remove this shield. I do not think that shield was removed before, but that may not be our concern right now. The area looks good. Yeah. Let's not worry about this part for now. We cannot do anything here anyway, other than clean. But we do not have any corrosion. So this side of the board, I do not see anything obvious, but that does not mean that we do not have a problem on this side of the board. We may have a short circuit somewhere on any one of the caps or ICs or whatever the case may be, but nothing obvious is standing out right now. We do see that red sticker. Could mean a lot of things. It helps if you have a good quality microscope like the one that we are using now, the NorthridgeFix microscope. We have the red version now with the measuring tool. It's up on our site. You can buy all your tools from our site. This microscope, anti-glare light, the ring light. The microscope does come with the big lens and 2 Barlow lenses, 0.5 and 0.75. And we do carry the articulating arm, also the NorthridgeFix articulating arm. You can buy everything from soldering stations, hot air stations, thermal cameras, power supplies, voltage injection tools, Flux, braid wig, everything. Just add to cart, check out, pay, and we almost always ship out same day. Now I see, the damage that I see is mainly on this side of the board. A lot of things going on this side of the board. Why not take it one step at a time? And if we measure to ground, do we have a short here? We do not. So the fuse is short into itself, but it's not short into ground. That's good. This inductor looks discolored, but it's good. Do we have a short circuit on those caps? We do not. And we do not. And we do not. I'm reading 0.1 voltage drop, which is okay. 0 ohm resistor. I'm just trying to figure out if we have a short circuit on any one of the caps. And we do not. It may be that we have faulty CD chips, whether it's this one, or both. Let's measure the cap, even though it looks good, but just, oh, 0 voltage drop. That's that short. Let me go to resistance mode. And if we measure from here to here, I'm reading 0 ohm resistance. That's that short. Now the short could be caused by the CD chip or something else on the board. If we measure a similar cap that we have under this CD chip, we should have a resistance of about, assuming this is not shorted, 1.8 mega ohms. Big number. And if we read in diode mode, we have 0.57 voltage drop. So we know that we have a problem right here. Now the problem could be the component itself, it could be the CD chip, or it could be any one of the components that connects directly with this capacitor. We have a fuse here. Let's measure it. The fuse is good, and if we measure it to ground, fuse to ground, do we have a short? And we do. Look at this. We have a short circuit on the fuse. The fuse should be shorting to itself, but not to ground. If we measure it to ground, we have a short circuit. So it could be that something is shorting out. This one is a diode. This one is a diode. We may have a problem with either one of the diodes that may be shorting out the fuse or and cap. We're going to have to pull up the board view diagram and see what connects with this capacitor. But right off the bat, I do see a burn mark right here. Right? It's not too clear. Let's pull up the board diagram. And the board number, what's the board number on this? And the board number is A20-01521-A. Right now I need to orient that board so it matches the orientation of the board on my bench. The angle that you see here is to my left. So we're gonna flip it, flip that board, and we have one CD chip right here. We have one CD chip right here, and the capacitor that we are interested in is this guy right here. What connects with that cap? Look at this. The fuse connects with the cap, the top diode connects with the cap, and the bottom diode connects with the cap. D3301, D3300, and the fuse, F3000. They all connect with the cap. We're going to start with the diode, specifically the one on top, and see if that will solve our short. Hopefully it does. Back to the motherboard, so we can compare what we saw on the board view diagram and the board. It looks bad, but maybe the diode is good. So it's mainly this guy, or the chip, or the component itself. If we flip the board, I'm interested in the caps or in the components that we have on the back here. They look like they may be caps. If we flip the board, and look at this. We do have a lot of corroded capacitors here, and I'm sure every single one of them is going to measure for a short. And any one of them could be causing the short. Who knows? Measure from here to here. See? They're all connecting in parallel. If we measure here, we also have a short. We also have a short. And that's basically it. Those capacitors are separate. I think they are. Yeah, they are separate. Based on the board view diagram, those caps are separate. So we are interested in those caps, in the two diodes, the capacitor itself, or the CD chip. You see, we just narrowed it down to those components. We can start by desoldering the top diode and see if we still have a short. That diode is out. Let's keep it on the side for now. I do not know if that diode is what's causing the short, so we're going to keep it on the side. If we still have a short, then we're going to put it back. Unless we have more than one shorted component, then it's going to become more tricky. Meter in diode mode. And we're going to measure for a short again. Measure right here. That's probably ground. And measure here. And look at this. Wow. Wow. We got rid of the short. So my assumption that this component does not look good is valid. Wow. Few minutes in, and we already got it. We're gonna measure that capacitor one more time. Do we still have a short right here? And we do not. We no longer have a short. If we measure to ground, you see, we do not have a short anymore. 0.526 voltage drop. We got it. We got it. That's amazing. I got a donor board right next to me. Right here. And we're gonna remove that component from the donor, and we're gonna solder it on the customer's board after I take that phone call. 1 minute. We have the diode right here from the donor. We're gonna remove it and solder it on the customer's board, and hopefully that will solve the problem. Let me add some flux. We're gonna tin those pads, and we do not need this faulty diode anymore. See, if we measure it on the back, if we measure from here to here, we have a short. And if we flip it and measure it from here to here, we have a short. So the diode is faulty. All right, so we did an awesome job. I'm gonna hand this over to Big Boss to reassemble and test, and I'll be back to finish the video. All right, so I handed the motherboard over to Big Boss to reassemble and test. I have good news and bad news. One thing I forgot to mention when I started working on this motherboard was one of the ports was completely not working, and just the other port was displaying 5 volts and not 19 volts. Both ports should be showing 19 volts and not just one of them. But on this particular laptop, for this particular case, one of the ports was not working and the other one was displaying 5 volts. After we did what we did, we replaced the diode. Now both ports are working. One port, however, is displaying 5 volts and the other one is fluctuating between 19 volts to 5 volts. 19.5, 19.5. We replaced the battery, nothing changed. And right now I have a very strong reason to believe that we may have an issue with the CD chips. It could be either one of the CD chips, but we do not know which one. Anytime we have a problem with the CD chip, it's always better to change both chips because one of them can cause damage to the other one. So we're gonna have to replace both CD chips, and I will most definitely do a video on this if it ended up being a success. Right now it's end of the day. I'm gonna continue working on it. I will work on this one probably tomorrow. I have a lot of things on my bench. If I do not get to it tomorrow, probably sometime this week. So I will let you know. If I do not post a video, I will at least post a comment and pin it and let you know what happened. But for now, we're going to end the video right here. I hope you enjoyed it. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe. And we'll do something else in the next video.